I was all set to make videos about my work in December until I started writing an example of a user-defined macro, an example that would have benefited from the new switch expression from C#8. But I hadn't actually implemented the switch expression in the parser yet. Partly this is because no one had asked for the feature, partly because the feature has a very tricky syntax, and partly because I knew that the Microsoft team had decided to introduce a new pattern matching syntax that was incompatible with the pattern matching syntax I'd already added to enhance C# a couple of years earlier. Not to mention the fact that C# also added pattern matching to the case statement in the switch statement, and that change doesn't look compatible with a key feature of enhanced C#. You can see what I'm talking about in this example. You can pass a syntax tree to this method, and it will return a string indicating what kind of syntax tree it saw. The match code macro expects a list of case statements, and the case statement simply expects a list of expressions. Microsoft's new pattern syntax is incompatible with this. Nevertheless, I pressed forward and attempted to implement the new pattern matching syntax, first for the is operator and then for the switch expression. It took me about a day to figure out how to approach the problem, because the new syntax is ridiculously ambiguous. For example, what is x, y in the x comma y in this expression? Well, according to the official grammar, this is three different kinds of patterns simultaneously. It is a tuple type, it is a tuple value, and it is also a positional pattern. So how the hell am I going to parse something that might have three different interpretations? I did figure it out though in the end. So in addition to writing 4 pages of notes and a rant about how poorly the switch expression is designed, I realized I would have to add a new feature to my parser generator, LLLPG, in order to create a recognizer that worked the way I needed it to. A recognizer is a special version of a rule whose only job is to scan ahead in the input to figure out whether the source code matches that rule. Since LLLPG is an LLK parser generator, it does not support unlimited automatic look-ahead. Instead, you need to scan ahead manually using a zero-width assertion denoted by the ampersand operator, as exemplified here. The zero-width assertion invokes a recognizer function which does support unlimited look-ahead and returns true if the match was successful. But it turned out that I needed a recognizer function that was slightly different than the recognizer that LLLPG would generate automatically. So I did it. I added 2 new keywords to LLLPG called recognizer and non-recognizer, which allow the behavior of a recognizer to be customized. After that, I was able to finish support for pattern matching in both the switch expression and in the is expression. And here's the proof that it actually does understand switch expressions, although there seems to be a problem with bonus new lines in the output. Ironically, by the time I was done all this, I had forgotten what I intended to use the switch expression for in the first place. And by the way, there won't be a video for the second week of January because I spent the week making videos and translating them to Spanish. I really need to practice my Spanish, okay? As for whether there will be more videos after that, well, I'm not a fortune teller.